Hi folks, Mr. Marshall, physics teacher. Today your task is going to be to do a library research assignment based on thermoelectric generators. This is what we were working on with the thermocouple lab, where you can basically measure the heat of an object by measuring the temperature, the voltage created from two different metals. When metals of different temperature are touching, they'll actually share electrons, and the number of electrons will give you a voltage sense. So at any rate, there's a technology called a thermoelectric generator, where they take a huge number of these thermocouples. Each one generates a tiny voltage. All right. And they take these tiny voltages and they add them all up in series so that you get a large enough voltage to power a device. This is used for things like satellites. What they do for a satellite is they'll take a lump of radioactive material and they will put it inside the satellite. So it's hot inside and outside of space is cold. So you've got this temperature difference. They line the warm inside core of the satellite with these thermocouples, and the change in temperature, so you've got a warm metal and a cold metal that are sharing electrons, and that's generating enough voltage for that satellite to be able to have the energy needed to send radio signals or something like that. So this technology has been around for a while. They've recently started to nanotech the stuff so that it's strong enough to generate useful voltages. They can actually replace alternators with them in some cars. Volkswagen is lining exhaust pipes with it. Lining the exhaust pipes with thermocouples means once the engine heats up, it's generating enough voltage from that wasted heat to recharge the battery. Don't need the alternator anymore. You save both energy from the flywheel, and you also save weight from the alternator. Your research assignment is going to be on radioisotope thermoelectric generators that they used here on Earth. Back during the Cold War, Russia would have submarine station in Vladivostok by the Pacific and command and control in Moscow. And because those two places are so far away, but they're over a round planet, so radio signals wouldn't be able to get from one end to the other. So you needed some antenna arrays to carry signals from Moscow around the curve of the planet all the way to those subpens so that they could communicate in case of a war. During the Cold War, the location of these antenna relay stations was kept secret. They didn't want them to be sabotaged, cutting off all the communication. They also didn't want them easy to be found, so they didn't trace huge power lines across the Siberian tundra. Instead, what they did is they created these radioisotope thermoelectric generators. They take a piece of radioactive material, put it in a can. Outside is the cold of Siberia, so you've got this temperature difference. It's creating enough voltage to power just a simple radio relay station. And they had them scattered about the tundra, so if a couple of them got knocked out, there would still be enough so that if there was a nuclear war, they'd be able to get their signals out. So it was obviously a pretty great idea for them. When the Cold War ended, Soviet Union toppled, the location of these top secret radioisotope thermoelectric generators was completely lost. So they're basically just hiding in the Arctic. Every 10 to 20 years, one of them shows up when a metal scavenger brings one in, it gets cracked open, and radiation leaks all over the North Sea or something like that. In the 80s, there was one where a hunter was camping out and he saw a big melted spot, found the canister, brought it back to his village. When he opened it up, it was just warm flakes of pink that he'd throw up in the air. The kids in the village would catch it on their tongue because it was warm and tingly, and boom, entire village comes down with cancer. So you've got a handful of questions. The first day you're in the library. First day you're in the library, Ms. Mastrocola is going to show you how to cite sources. Some of you may have cited sources in APA format before. She's going to remind you how to do that because you should have a source for all this information. You're going to answer about 7 questions on those thermoelectric generators, and you've got 2 days to do it, so I think it should be pretty accomplishable. The first one is just what is a thermoelectric generator? We kind of talked about that already. What are some of the applications they were commonly used for? And what are they still used for? The third one, what is the size and weight of an RTG? So basically find one. There are a lot of them that are known and some specs for the ones that are unknown. But find the size and the weight of one of them, because again, some of these things are literally being carried off by people. The fourth one, how much electrical power? Power is measured in watts. Are we talking about a city block, or are we talking about a PlayStation 3 is the question of that. How much radioactive material? And the real question there is it dangerous? Because a kilogram of radioactive material may not answer the is it dangerous. You should be able to think that one out. All right. The question number 6 is talking about an accident where radiological thermoelectric generators were used. These happened a lot in the Arctic because they were used for lighthouses a lot, and with shifting ice and oceans, they just got lost into the water. The Bellona site that I list on the back of this actually has a good list of all of those accidents. The last question is, do you think these could ever be used as a battery for like a household cell phone or something like that? And you can think about some of the things we've gone over with electrical power and their dangers, try to make an informed answer on that. For each one of these questions, I want it to be clear and complete. I don't want to have to refer back to the question to know what you're answering. So you can't say, yes, I think this should be used as a battery, because this yes is answering a question. So say this could be used for a battery or this couldn't. If you start out by saying yes, then you're already answering a question, and that's not what I want. How much power can an RTG produce? You're not saying 10 watts. You're saying an average RTG can produce blank amount of power. So answer in a complete sentence. Don't use pronouns, so limit your use of it, that, whatever. There's a lot of things we're dealing with in this assignment, so watch your pronouns. And cite sources. So, like I said, Miss Mastrocola will explain how that's done. Basically, for each one of these questions, you have to find information from somewhere. So I want you to tell me what that source of information is. And there's an appropriate way to cite it called APA. American Psychological Association has come up with a way to refer to documents, and that's the standard I want you to use. Ms. Mastrocola will explain it. So for each question, tell me where you got the information. Okay, and you've got 2 days to do this, so use your time well. All right, good luck.